Okay, good day everyone. I believe you've learned a lot of things so far. We thank God for the privilege to learn those things. So today we're going to be talking about radioactivity. So under this topic, we're talking about radioactivity. So this is a particular section or topic in physics, whereby it is a bit complex. You understand? So I'm just going to be teaching you something what I call decay constant, half-life. Now you can calculate that. So now note, this is the information. The information is, as long as you've registered for this course, you'll be getting updates on new courses I drop that covers other areas of physics. Do you understand? But let's get to the point. Let's get to the main. Do you understand? So talking about radioactivity, what do you understand about radioactivity? Radioactivity is the spontaneous decay or disintegration of the nucleus of the atom of an element during which some atoms are emitted, like the alpha, the gamma, and the beta rays, or a combination of any or all of the three, and energy or heat. Do you understand? So the definition, you can know that, you can check that in your all available materials under physics. Do you understand? So now radioactive elements include those elements that spontaneously emit radiation from their nucleus. So they consist of elements that radiates like continuously emits radiation. They emit radiation, do you understand? From the nucleus, e.g., we have radium, we have thorium, we have radon, we have ionium, we have polonium, etc. But that was my focus in all of my videos. I'm just trying to help you approach any question you see under the courses I've been able to create by the privilege of God, to approach them with confidence, do you understand, and getting a good result, good grades in your academics, in your colleges, in, making yourself proud of yourself, your parents, your tutors, and your various colleges. Do you understand that? So let's get to the point. So I'm going to talk about half-life. There's something we call half-life. That's T half. Most times it's denoted by this T half. Open attention. So okay, let me use this. That's T half. Yeah, this is okay. So this is what we call half-life. Open attention. So they say half of a radioactive element. Open attention. Half of a radioactive element is the time taken for half of the atoms initially present in the element to decay. So it's time taken for half of the atom initially present in the element to decay. Do we understand that? So there's another thing we call it decay constant. Do you understand? Decay constant. So whenever you hear something about decay constant, this is what it means. So the rate of radioactive elements is found to be proportional to the number of atoms of the material present. So we have something like this. The rate. So whenever you hear rate, that's D, and this is the number of atoms over T n. Okay. So when we introduce the decay constant, we have something like this. When we introduce the decay constant, so it turns to instead of using K, we use lambda. Do you understand? So we have something like dn dt is equal to lambda n. So you can take the minus to this side, so you have dn, okay? We have dn over dt minus what? Lambda n. Open attention. So let's make lambda the subject of the formula. So you have something like lambda, okay? Lambda is equal to dn over dt minus 1 over n. So we have the decay constant, formula for decay constant as this. Do we understand that? So, okay, the decay constant is no of atoms disintegrating per second. Do we understand that? So now, no of atoms source at that time. So we have a general formula. So whenever you introduce differentiation or integration into this, you have this general formula given as this. N is equal to NO is is, okay, minus lambda T. So this is a general formula given whenever you want to solve something under the equal signs or radioactivity or time, right? So let's have this in mind during the time. So now what is NO? NO is the number of atoms present at time T when T is equal to 0, i.e. at the time when observation of decay they have begun. And M is the number of atoms present at time T. So let's speak on this. Okay, so what I want us to literally do now, I want us to solve this question. I want to teach you how to solve it. It said, a certain radioactive element has a half-life of 10 years. How long will it take to lose 7/8 of its atom originally present? And it said, how long will it take until 1/4 of the atoms originally present remain unchanged? So here's the way to solve this. Now, they said they're doing the half-life as 10 years. Do you understand? So, we have, okay, let me play this. Okay, then let me just continue from here. We have to do like this. Do you understand? So, they're giving us T out as 10 years. Okay, so, now listen to this. The more this increases by half, the more this multiplies by 2. Are you paying attention? So the more this decreases by half, the more this is divided by 2. Are you paying attention? So if you want to increase this by half, so we have multiply 1 over 2, so we have T quarter. So this will multiply by 2, that's 20 years. Are you paying attention? So multiply this one by 1 over 2, T 1/8. So what? 40 years. So let's assume 1 over 2 multiplied by that T 16, 1/16. So T 1 over 16 to be what? 80 years. So here's what I'm saying. They said for half of this number of atoms to decay, for half of it to decay, it's going to take 10 years. I'll pay attention. So for quarter of that number of atoms to decay, it's going to take 20 years. For 1/8 of the number of atoms to decay, it's going to take 40 years. And for 1/16 of the atom to decay, it's going to take 80 years. Do we understand that? So we now ask now, how long will it take 7/8 of its atom original present to decay? So whenever you see something over 8, that is something over 8. So it's going to fall between 40 years. Do you understand? So the answer there is for 7/8 of the atom to decay, it's going to take 40 years. Open attention. So now, when I say how long will it take until 1/4 of the atom originally present to remain unchanged? That's 1/4. So 1/4 of it is what? 20 years. So that's what we have. 1/4 of the atom or of the element, I don't know. The what? 20 years. So thank you so much for watching this video. I really appreciate it. Whenever you're watching this video, please like, subscribe, and hit the subscription button to get more updates on my videos on physics, solving more examples, more exercises, and it's going to be a wonderful time. Thank you so much. I really appreciate it. My name is Solomon, and I am your online coach. I also teach mathematics, I teach physics during this time. So I'm going to also be creating more courses on mathematics, whereby it's going to be the speed of calculating mathematics. So stay tuned. See you next time. Don't organize it. More videos are coming during this time. More videos coming. Stay tuned. So many examples of these topics I'm able to explain. So this is just the course you have registered for. So the bonuses are more others of video on solving a lot of examples and other aspects of physics. And as we work together, we're going to have a good grade in academy. I believe this has helped you. Send me a message, a reply, how this is helping you, and I work together. Thank you for your message.